Hello everybody, welcome once again to another interesting quantitative aptitude video from CareerRide.com. Our topic for today is Algebra. And as all of you know, this is again a very important topic from the point of view of your placement test and entrance exams also. Because in most of the papers, you will find at least 4 to 5 questions appearing from this topic. A lot of students find these questions from Algebra to be very difficult, scary, lengthy, but trust me, all of these questions can be very easy if you can just apply the tricks and if you know the concepts behind those tricks. So once again in today's video, I'll try to clear your concepts and tell you the tricks so that you don't have to mug them up and you can apply them to solve your questions in a time efficient and effective manner. So let's begin. Okay, so now to begin with, let me first of all tell you what is going to be the flow of this video, how the content in this video is going to flow. So if you have taken a look at the chapter Algebra, you yourself know that this chapter looks a little lengthy. But if you look into the depth, you'll see that there are majorly 4 to 5 major concepts based on which the whole chapter rests and based on which the questions are asked to you. So what I'm going to do in this video is I'm going to teach you the concepts and then the tricks related to them, and then we'll solve the questions based on them. Okay, the first thing that we are going to see is those solving those remainder and factors type of questions. So I'll tell you some very easy concepts and some very easy tricks so that you can solve the questions in a very effective time efficient manner within seconds. Okay, the second type of questions that you find in this chapter are from the section like where you have to solve lengthy rational expressions and you have to find the answers to those lengthy expressions. Okay, so what I'm going to do is to solve this section, I'm going to discuss the tricks, some very easy tricks so that you can solve these lengthy expressions, rational expressions in a very easy and time effective manner again, and these algebraic expressions will become very easy for you. The third variety of questions that you usually find in this paper on algebra is those type of questions where you are given the value of x plus 1 upon x, for example, and you are asked to find maybe x cube plus 1 upon x cube or something like that. Okay, so we are going to learn to solve these type of questions also very easily in this video. Okay, and you will be able to solve each of these questions within seconds. Okay, and the important thing to know here is that we are going to solve a lot of varieties of questions based on each of these concepts. So make sure that you solve each question along with me. Okay, let's start. Okay, so to begin with, let us talk about a polynomial that is given to you in the paper. For example, let's say our polynomial is 57x cube plus 29x square plus 17x plus 42 and you are asked to divide it by x plus a. I'm denoting my polynomial by what? Fx. I'm denoting by fx. Okay, so now for a moment, assume yourself solving this question taking a traditional approach where you take the polynomial fx, you divide it by x plus a and you try to find the remainder here. Now if you take this traditional approach, there's a high possibility that you'll spend a lot of time from your afternoon trying to solve just this one question without getting a chance to move on to the next one even. Okay, but is that the right way out? Definitely not. There's a very easy way out to solve this kind of a question. What you have to do is you just simply equate this x plus a, your divisor, with 0. What is going to happen? You are going to get a value of x that is equal to minus a. Okay, simply place this value of x is equal to minus a in the polynomial that is given to you. So now my polynomial becomes 57 minus a cube plus 29 minus a square plus 17 into minus a plus 42, and this is going to give me some value. Okay, right now it is minus a, but in the question, in the actual question, you may find it to be your a to be this to be minus 2, minus 3, minus 4 or whatever is given to you in the question. But when you place that value in the polynomial, the answer that you are going to find is actually your remainder. Isn't it interesting? This is nothing but the application of remainder theorem that we have learnt in the past classes. If you do not remember learning it, absolutely okay, no problem, because you have learnt it now. So to solve this kind of a question, make use of this remainder theorems application. Okay, this is a very basic thing that I have begun with. Now we will see further in the video how examiners complicate this kind of a question. Okay, now we divided it by x plus a at the moment. Now assume that you are asked to divide it by x minus a. What is going to happen in that case? Again, equate it with 0. This is going to give you a value of x, that is x is equal to a. So in this case, place x is equal to a in the polynomial, right? And whatever answer you find is going to be your remainder. Now let us assume that rather than giving you such straight divisors, they give you ax plus b divide your polynomial by, let us say, ax plus b. What is going to happen in this case? In this case, again, let us equate it with 0. Okay, what is going to happen? X is equal to minus b by a is what I'm going to get. Place this in place of x, and whatever value you find, that is going to be your remainder. Very easy. Taking this approach, you can solve this kind of questions within seconds. Okay, now another important thing to remember here is this. If they have given you in the question that your divisor absolutely, completely or exactly divides the polynomial, it means nothing but that your remainder is equal to 0, right? 18 is completely divided by 2, or 2 completely divides 18. What does this mean to me? It means to me that my remainder is 0, right? Similarly here, if your divisor completely divides your polynomial, it absolutely divides your polynomial, or it exactly divides your polynomial, it means your remainder is equal to 0, right? This is a very important thing which you are going to use further in the question, so bear it in mind. Okay, let's move on to some practice questions now. Okay, so to begin with, let us take a very simple and straightforward question where a polynomial is given to you. 4x cube plus 13x square minus 5x plus 1. This is the polynomial that is given to you, and you have to divide it by x plus 4, and you have to find the remainder. Very simple and straight question. We have already seen x plus 4 becomes equal to 0. This is what I equated to, and from here I get x is equal to minus 4. What do I have to do now? I simply have to place this value x is equal to minus 4 in the polynomial. So what does it become? It becomes 4 into minus 4 cube plus 13 into minus 4 square minus 5 into minus 4 plus 1. What is this? This is equal to minus 128 plus 13 into 16 is what? 160 plus 48, that is 208 plus 20 plus 1, right? So this is what? This is equal to 229 minus 128, that is equal to 101, and this is nothing but your remainder. Okay, so you see, by taking this approach, how easily you can solve these questions, right? Now, as I took this much of time also because I was trying to explain you the things. Otherwise, I would have simply jumped to this step and I would have solved this question in not more than 25 seconds. Okay, so these type of questions can be very easy if you take the right approach. Let us see another question. And the next question is 5x cube minus 3x square plus cx plus 2. This is my polynomial that is given to me, is to be divided by x plus 3. It means x is equal to minus 3 here. Find the value of c if the remainder is 5. A very easy question, nothing difficult at all. Just an application of what we have already learned. Okay, so what do we have to do here? We just have to put the value of x is equal to minus 3 in this polynomial. Okay, so 5 into minus 3 cube minus 3 into 9 plus c into minus 3 plus 2, and this is giving me what? This is giving me the remainder 5. That is all given to me. Okay, so 3 3s are 9, 3s are 27 into 5 is minus 135 minus 27 minus 3c plus 2 is equal to 5. Can I exchange the sides? Yes, very easily. So 3c is equal to what? Minus 140 minus 25, right? So minus 165 is equal to 3c, which gives me c is equal to minus 165 upon 3, which is nothing but minus 55. 5. See how easily I found out the value of C by making the use of the remainder theorem. Okay, very easy concept, very easy trick which can help you solve the questions in just maybe say 20-25 seconds. See, again I'm telling you, I took the time because I was explaining you the things. Otherwise, what I would do, I would simply straight away jump to this step, right? And the question will become very simple and easier for me, and I'll be able to solve it within 25 seconds. All that you have to do is practice sufficiently and make your mathematical calculations faster. Okay, and the only trick to do that is practice. Okay, so now let us move on to question number 3, and it is x to the power 529 minus 1 divided by x minus 1. Find the remainder. Now see, a lot of you may have found this question to be very difficult and scary if you were not aware of the trick that we just learned. But with the help of our trick, you know that this question is very easy and you don't even need to solve this kind of a question. Okay, you can simply mark the answer straight away, because now you know that x is equal to 1 is the value that you have to place in this polynomial. Okay, so what you would do, 1 to the power 529 minus 1 is equal to what? It is going to be equal to 1 minus 1, because whatever power of 1 I may take it to be, the value is always going to turn out to be 1. Okay, so the answer is nothing but 0. So in the real world, if I was aware of that trick, I would not even solve this question. I would just mark the answer and I would get the answer in 5 seconds. Just as I read the question, I would get the answer. Okay, so very easy, you see. But now see, if rather than x minus 1, the value was given to you x plus 1. If you had to divide it by x plus 1, then what would happen? In that case, x is equal to minus 1 would be the value you will have to place in the polynomial, right? So minus 1 to the power 529 minus 1. Now it is the odd power of minus 1. So this is going to give me minus 1, right? Minus 1, the answer is going to be minus 2 in this case. So pay attention what you are asked to divide it with. Is it x plus 1 or x minus 1? That is the only thing you have to pay attention to. Otherwise, this is a very easy type of a question. Okay, let's move on to the next one. Question number 4. 3x cube plus 6x square plus 4a divided by x square minus 4 leaves out the remainder 12x. Find the value of a in the expression. Okay, so what is given to me here? It is x square minus 4. So my x square is equal to 4. And this is the value I am directly going to place in my expression. And this question is again nothing but an application of what we have already learned and what we have already done. So let us place the value of x square is equal to 4 in the expression. Okay, what does this give me? 3 into 4 is 12. So this gives me 12x plus 6x square. So 6 4s are 24 plus 4a, and this is giving me the remainder 12x, right? So from here, from both the sides, I can just cancel out 12x and 12x. What does this give me? 4a is equal to minus 24 and a is equal to minus 6. See, very very and very time efficient method. But many of you may wonder, why did I not take x is equal to 2? Why did I not solve this further? X square is equal to 4 is what I had. But why did I not make it x is equal to plus minus 2? I did this because I wanted to avoid lengthy calculations. And how did I notice this? Because I noticed that the remainder given to me is 12x, right? So if I had taken the value of x is equal to plus or minus 2, I would have made my calculations lengthier, right? Because in that case, I would not have been able to cancel this out. And how do you notice these things? These things you notice along with the practice. So what is more important? Important thing is to learn and then to practice so that you can notice these kind of things, right? Otherwise, the question is not difficult at all. Very easy question. You can solve it just within a jiffy. Let's move on to the next one. Question number 5. X to the power 1001 plus 5x to the power 999 plus a is completely divisible by x plus 1. Find the value of a. Now see, if you had not known the trick that we have just learned in some time back, this question again would look very difficult to you. But with the help of our trick, this is again a very easy question to solve. Nothing difficult at all about it. Okay, there's no need to get panicked when you see these type of questions. From here, what do I have? I have x is equal to -1. Okay, and this is all I have to place in my expression here. Okay, so -1 to the power 1001. This is an odd power, so it is going to give me -1 plus 5 into, again, x is -1 and it is to the power odd. 999 is an odd power, so it is going to give me -1 again. Okay, plus a. Now there is nothing given to me here for the other side of the equal to sign, but it is given to me in the question that it is completely divisible. And we learnt initially that whenever the words completely, exactly, absolutely divisible are used, it means the remainder is 0. Okay, so it means when I place the value of x is equal to -1 in the expression, I'm going to get a 0 here. Okay, so what does this mean here? It means -6 plus a is equal to 0 and a is equal to 6 is all I had to find out here. Okay, question number 6. If 5 to the power x minus 5 to the power x minus 1 is equal to 500, find the value of x to the power x. Wow, so many x's here. Well, algebra in itself is a chapter of x's, finding your lost x. But stay alert. If you get lost into the thoughts of your x too much, be it your boyfriend or girlfriend, you're not going to be able to solve for x of algebra. So stay tuned, stay alert, and our purpose is to solve for x, not get lost into the thoughts of your x. Okay, so coming back to the question. So what I'll do here is I'll just take 5 to the power x minus 1 out. Okay, and what am I left with? I'm left with 5 minus 1 here. Okay, and what is it? It is equal to 500, right? So what does this give me? 5 to the power x minus 1 is equal to 500 divided by 4, which is nothing but 125, right? And I know that 125 is equal to 5 cube, right? Which means x minus 1 is equal to 3 and x is equal to 4. Now I don't have to stop here. I have to find the value of x to the power x. So which means 4 to the power 4. Now you know yourself that this is equal to nothing but 256. Nothing difficult here you see in these type of questions. All that you have to do is you have to apply what you already know. This was a little different question. It was not from remainder theorem, but I just included it to change the mood a little. Okay, now the next variety of questions from the chapter Algebra that are very popular with the examiners are where they give you lengthy algebraic expressions and they ask you to find the value of those expressions. Or there may be a case where they give you an algebraic expression, a lengthy algebraic expression in the question, and they give you 4 options. In the options also they give you the algebraic expressions which are simplified and they ask you to find out this expression in the question is similar to which of these. Then there can be cases where the number of equations are insufficient but the number of variables are more and you are expected to find the value of that expression. So in all these cases it becomes really tedious to solve the lengthy algebraic expression and find the value or find the answer. But in this case, a very powerful method that works wonders is the substitution method. So for the time being, just listen to what I'm saying because I'm going to explain you everything with the help of practical examples and questions. So things will become very clear. Just for the time being, pay attention to what I'm saying. Okay. So what you do in this method is you assume the values of the variables. Okay. And you can assume the values to be the smaller values because that makes the calculations easier. So for example, if there is an algebraic expression which uses variables x, y, z or whatever, you may assume the values to be something like 0, 1, 2 or easier values which makes the algebraic expression work also and you can find the answer also. Then you substitute these values of the variables in the actual expression and you find the answer. The method, as I said, works wonders, is very time efficient and very effective. Okay. The only thing that you have to take care of is that when you assume the values, assume such values that don't make the denominator 0. Okay. For example, you have an algebraic expression where numerator is anything say n and let us say the denominator is for example x minus 1. So I'll try to avoid using x is equal to 1. I'll not assume x is equal to 1 in this case because that is going to make my denominator 0, which is something I don't want, right? Why I don't want? Because anything by 0 becomes undefined, okay? And then I will not be able to solve that expression, okay? So this is the only tip from my side for the time being. Just pay attention to this, that we don't make the denominator 0. And with the help of questions that we are going to take from here, things will become pretty clear to you, okay? So now let us try to solve some questions using this substitution method, okay? Now the question number 7 here tells me, express the following as rational expression, and an expression is given to me, that is 2 into x plus 3 divided by 3 into x minus 2 minus 2 into x plus 1 divided by 3 into x minus 3. And I am given 4 options here, and I have to find out this expression in the question is similar to which of the following, okay? Now if I take the complete solution method, that is a lengthy method, and try to solve this, solving numerator and denominator, this is going to become very lengthy. But there is a very easy way out, as I told you, with substitution. So in substitution, I told you that we can assume the value of the variable, okay? So the variable that we have got here is only one, and it is x, okay? So I can assume the value of x to be 0, 1, 2 or 3. But I also told you one more thing, and I told you that I'll try not to make my denominator 0, and I'll assume a safe value of x. But when I look at my denominators in the question, see, it is x minus 2. So x minus 2, if I take x to be 2, my denominator will become 0. Now see the next denominator, 3 into x minus 3. So if I assume my x to be 3, again my denominator will become 0. So I cannot assume it to be 2 or 3. Now let us go to the options. In options, I see the first option, and I see that x minus 1 is there in the denominator in the first option, right? So if I take x to be 1, again the denominator will become 0. It means 1, 2 and 3 is equal to x. These are not my possibilities. What is my possibility? My easiest possibility is x is equal to 0 here, okay? So I'll just place the value of x is equal to, first of all, in the expression given to me in the question, okay? So in the question, the expression given to me is 2x plus 3 upon 3 into x minus 2, okay? Let me place the value of x is equal to 0. What does it become? It becomes 2 into 0 plus 3 is what? 3 divided by 3 into x is again 0. So this becomes just minus 2 minus 2 into 1 divided by 3 into minus 3, right? What does this give me? This gives me minus 1 plus 2 upon 9. What is this? This is equal to minus 7 upon 9. So this is actually the value of the expression given to me in the question, right? Now I am trying to find out which of the options here matches this value if I place x to be 0, okay? So my option number A is what? 2 upon 3. X minus 7 is what? X is 0. So this becomes minus 7 upon 6 into minus 1, right? What is this? This is equal to 2 upon 3 into minus 7 upon minus 6, right? This is nothing but minus 14 upon minus 18. This is equal to 7 upon 9, which is not equal to the answer I got in the question, right? When I solve the expression in the question. So this is not my correct option. What happens in case of B? In case of B, 2 into 7, because x is 0, 3 into minus 3 into minus 2. What does this give me? This gives me 14 upon 18. This is again 7 upon 9, but my expression when I solved the question, it was minus 7 upon 9. So B is also not my option. Let me check out C and D now. What happens in case of C? C, it becomes minus 14 because I have taken x to be 0. So it becomes minus 14 divided by 3 into minus 2 and plus 3. So this gives me minus 14 upon minus 18 again. This is again 7 upon 9, not my option because I'm looking for minus 7 upon 9. So let me check out the option D. The option D here is 2 into minus 7 divided by 3 into 0 minus 3 is minus 3 into minus 2. This is what? This is equal to minus 14 upon 18. This is equal to minus 7 upon 9, which is what I was looking for. And this is same as the value of the expression I got in the question. Okay, minus 7 upon 9 was the value of the expression when I placed x equal to 0. And D also gives me the same value when I place x is equal to 0. So D is my correct option. See, so basically I was trying to tell you that rather than solving this expression completely given to you in the question and trying to tally it with one of these, a better way out is choose a value of the variable here and try to bring it into the numerical values. It becomes easier to compare and easier to calculate. Okay. If you find it confusing anywhere, you can pause the video here and you can take a good look at this question assuming x is equal to 0. I have not taken x is equal to 1, 2 or 3 because I did not want to make my denominators 0 either in the question or in the options. Okay, so that is why I have assumed x to be 0. See, once you know how to use the substitution method and use it to solve the questions quickly, you will take hardly 40 to 45 seconds to solve this kind of a question. Because you will just directly place the value of x is equal to 0 in the question and in the options, and you will start getting the numerical values. The reason I took so longer was because I was trying to explain you everything. Otherwise, I would just find these direct numerical values, minus 7 upon 9. For the options, I will find 7 upon 9, this 7 upon 9, 7 upon 9, minus 7 upon 9 for the D option. And I would quickly try to see which one matches. Okay. So this is not going to take, this is not a lengthy method. It is not going to take too much of time. Don't be scared at all to use this method. Okay, now let us see one more question and try to solve it using the substitution method. The question given to us is a plus 1 divided by a minus 1 plus a minus 1 upon a plus 1. This expression is similar to which of the given options? Now, in the substitution method, I can assume the value of a to be anything and I'll try to make it as small as possible. So it can be 0, 1, 2, 3 as you know. So let me see what is the value of a that I should consider first of all. When I look at the denominator of the question, I see that I have a minus 1, which means that if I take a is equal to 1, my denominator will become 0, which is something I don't want. So I'll assume my a to be 0. Okay, this is even easier. Okay, so let us try to place a is equal to 0 in the expression given in the question first. So what do I have? I have 1 upon minus 1 because a is 0 plus minus 1 upon 1. This is equal to what? This is equal to minus 2. This is the value I'm looking for actually. Okay. So my option number 1 is what? Option number 1 is 1 upon 2 into 0 minus 1. This is equal to minus 1 upon 2. No, this is not my correct option because this is not similar to the answer I got in the question. Okay. Now see the second one. This is equal to 1 upon minus 1. This is equal to minus 1. Again, not my option. Let us look at the third one. This is equal to what? 2 into 1 upon minus 1. This is equal to minus 2. This is what I was looking for. Okay. So this should be my correct option still. I'll just show you why fourth one is not. Okay. So this is equal to minus 1 because a is equal to 0. So upon 1, this is equal to minus 1. So you see, putting the value of a is equal to 0 saves me from so much of trouble. My correct option is option number 3. If you want, you can solve the question in the traditional method and you can try to equate this value and the option number 3 will come out to be same. Okay, let us move on to the next question now. And our question number 9 is find the sum of 3x square plus 4y upon x minus 4 and its reciprocal if x plus y is equal to 1. So first of all, let us see what is given and what is asked. So you are given an algebraic expression 3x square plus 4y upon x minus 4 and you have to add it to its reciprocal. So first of all, let us see what is its reciprocal. Its reciprocal would be just inverse of this. So it would be x minus 4 upon 3x square plus 4y. When you're trying to find the reciprocal, the positions of numerator and denominator change. The values in the denominator and numerator, they get exchanged with each other, right? So exactly that is what is happening here. So you are expected to find the sum of these two things. Now if you go by traditional method, you see how lengthy the calculations can get. You will have to find the LCM of these two things, then multiply, right? Things will become very lengthy. But using the power of substitution, we can solve this sum within seconds, okay? And let us try to do that. So first of all, let us see what is given to us in the question. It is given to us that x plus y is equal to 1. Okay. Now here there are two variables, x and y, but there is only one equation. So I cannot separately find the value of x and y. It's difficult for me here. But I can definitely assume the value of y, right? I can substitute the value of y to be anything that I want. So the easiest thing that I can do is, I do not want to make my denominator 0, right? So I'll assume y to be 0. This is the extra variable. There are two variables, one equation. So I'll assume one variable's value, okay? And I'll assume the value of y to be 0. So what happens in this case? Then my x becomes equal to 1. Now what do I have to do? I simply have to place the value of x in this first expression, okay? Let us try to do that and let us try to find out the answer now. So x is equal to 1. Now 3x square becomes 3 plus 4y. 4y becomes 0 upon 1 minus 4, right? Plus the reverse of this is what? X is 1. So 1 minus 4 upon 3 because y becomes 0, right? So what does this give me? This gives me 3 upon minus 3 plus minus 3 upon 3. Right, this is nothing but minus 1 plus minus 1. This is equal to minus 2. So the answer of this question is minus 2. Had you gone through the lengthy calculation method, had you tried to find the LCM and then tried to solve this would have become very lengthy. But using the power of substitution, you can solve this type of questions within 20 to 25 seconds. You will not even take this much of time with the practice, right? Because right now I was explaining you the things, otherwise I would have straight away started from this step, right? So I hope you have understood it. If there is any difficulty, you can pause the video here and take a good look, okay? Let's move on to the next one now. Okay, so moving on to another interesting question. Question number 10. If x plus 5y plus 3 is equal to 0, find the value of x cube plus 5y cube plus 12xy plus 27. Okay. So now if you look at this expression x cube plus 5y cube plus 12xy plus 27 and just assume that you don't know the method of substitution. If you find this question in your paper, many of you might get very scared, right? But with the power of substitution, I'm sure all of you will be able to solve this question very easily, okay? Let's see how to do it. So what is given to me? It is asked, first of all, let us see what is asked to me. It is asked to me x cube plus 5y cube plus 12xy plus 27. I have to find the value of this expression and it is given to me that x plus 5y plus 3 is equal to 0. One equation, two variables x and y. Okay, so I can assume the value of one of these variables. Now to make the calculations easier, again I am assuming y to be 0 here. So what happens in this case? X plus 0 plus 3 is equal to 0. This is from my equation that is given to me. So x becomes minus 3. Okay. Now let us try to place these values in the given expression where I have to find the value. So what happens here? As soon as I assume the value of y to be 0, right? This becomes 0, 5y cube becomes 0, 12xy becomes 0. What happens then? Then I am left with x cube plus 27 is all I am left with. Put the value of x is equal to minus 3 because we just found out minus 3 cube plus 27. What is it? This is equal to minus 27 plus 27. The answer is just 0. See, no lengthy calculations, nothing. I was explaining you, that is why I took so much of time also. Otherwise, I would have just solved this question straight away from this step. right? I would have assumed y to be 0 and just I have come to this, okay? And I would have solved this question within 10 seconds. Practice is the key, so make sure that you understand this type of questions, you understand the value of substitution, and you practice this type of questions. Okay, so let us see one more interesting question. Question number 11. If a plus b plus c is equal to 25 and a square plus b square plus c square is equal to 225, find the value of 4a square b square plus c into a minus b. Okay, but very easy question, don't get scared at all. Very easy to solve. All that you have to do is you have to use the power of substitution that you have just learned. Okay, now you have a magic wand in your hand which you can apply. Okay, so let us see first of all how many equations are there. There are two equations. A plus b plus c is equal to 25 is the first equation that I am given with, and the second equation I am given with is a square plus b square plus c square is equal to 225. So now you see there are two equations, but there are three variables, a, b and c, three variables. So I have got one extra variable here, and first of all I'll try to get rid of that. The safest thing I can do here is I can assume c to be 0, right? What happens in that case? In that case my a plus b becomes 25 and my a square plus b square becomes 225. Am I right? Okay. Let's see what I have to find out. I have to find out 4a square b square plus c into a minus b. Now just see. The moment I assume c equal to 0, okay, in this new expression we have to find the value. The moment I take the value of c to be 0, this becomes 0. This gets cancelled out, right? This gets finished. So what I'm left with? I'm left with only 4a square b square to find. Very easy now. Okay. Now let us see how to use this. Now I'm given with a plus b is equal to 25. This is my first equation, let me assume, and this is my second equation. So let me just try to square a plus b whole square. This is equal to what? This is equal to a square plus b square plus c square. A square plus b square plus 2ab, I'm sorry. Okay. So this becomes equal to what? The square of 25, taking squares on both the sides, right? So this becomes 625, right? I'm given the value of a square plus b square in the second equation. Let me place that. 225 plus 2ab is equal to 625, right? So my 2ab becomes what? 625 minus 225 is 400. Okay. So this is what I have come to. What do I want? I want 4a square b square. The value of this is what I want to find out. So what can I do? I can just square on both the sides, right? So let me take the square of both the sides, 2ab whole square and 400 whole square. So if I take my answer to be, this becomes 400 whole square, right? And if I have to simplify it further, it becomes what? 4 4s are 16 and 0 0 0 0. So this is the answer. You have to see in what form it is given to you. But this question is extremely easy. You don't have to get scared of these questions at all. Very simple, very easy. All that you have to do is you have to just move your magic wand and use the power of substitution. Okay. If you are confused, pause the video, take a good look. I'm sure things will become very easy for you and very clear to you. Okay. Let's move on to the next question now. Question number 12. X is equal to a plus 2 by a, y is equal to 2a minus 2 by a, and find the value of x square minus y square into y square plus 3 divided by x square minus 6. Again, a very easy question. All that you have to do is substitute the value. Okay, let us see how to do that. So what is given to me? X is equal to a plus 2 by a is what is given to me, and the other thing is y is equal to 2a minus 2 by a is what is the other thing given to me. Okay, and what do I have to find out? I have to find out the value for x square minus y square into y square plus 3 divided by x square minus 6. I have to find out the value for this expression. Okay, so coming back to what is given to me, there are two equations, x is equal to a plus 2 by a and y is equal to 2a minus 2 by a, right? And three variables, that is x, y and a. It means 2 equations, 3 variables, which means there is one extra variable which I'll have to substitute the value for. Okay. So now let us see that in this equations, I'm going to place the value for a because that is common here. Okay. So I do not want to make my denominator 0. So I cannot take a is equal to 0. So what will I do? I'll take a is equal to 1 in this case. Okay. Because I want the value to be smaller so that I can make easy calculations. But at the same time, I do not want my denominator should not be equal to 0. I do not want my denominator to be 0. Okay. So if I take a is equal to 1, what does a become? X become? X becomes 1 plus 2 by 1, that is equal to 3. And what does y become? Y is equal to 2a minus 2 by a. So y becomes 2 minus 2 by 1, right? So what is this? This is equal to 0. So it means x is equal to 3, y is equal to 0 is what I have here. Now let us place the values in the expression that I want to find out. So x square is 3 square, y square 0, y square again 0 plus 3 divided by x square means 9 minus 6. This is what? This is equal to 9 into 3 divided by 3. So the answer for this question is just 9. Very, very easy question. Nothing difficult at all. Pretty simple. All that you have to do is you have to use the power of substitution. Okay. Let's move on to the next one. Okay. Now see, I've put together a list of important formulas that you'll require to solve the questions from algebra. Especially if you've got the questions on substitution method or the next thing that we are going to talk about. These formulas, they are going to be very, very useful to you. The list that is in the left hand column. These are the basic formula that most of us know. We already know these formula, right? So there is nothing very special about the formula here. A plus b the whole square is equal to a square plus b square plus 2ab and the following things. All of us know these things, okay? But it is important to pay attention to them. The special thing is the formula on the right hand side. These are the derived formula which all of us know, but many a times we do not recollect them at the time when we need them. Okay. So this is also an important list which you must pay attention to. For example, if you see here a plus b the whole square can also be written as a minus b the whole square plus 4ab, right? If you require, you can try to solve these type of things in the notebook once, and so that they settle in your mind. Okay, I'm not going to solve each of these things because they are pretty simple, pretty basic, but very, very important. So make sure that you pay attention to all of these formula as well, because you are going to make use of them somewhere or the other when you solve the question, especially on substitution method. Okay. Now let us move on to the next variety of questions that you usually find in the exams. Okay, so now coming to another variety of questions that is very, very popular with the examiners. How many of you have seen this kind of a question in the exam papers? X plus 1 upon x is equal to a is given to you and you are expected to find out the value of x square plus 1 upon x square. Or where x minus 1 upon x is equal to a is given to you and you are again expected to find out the value of x square plus 1 upon x square. How many of you have seen this type of a question? And how many of you are scared of this kind of a question? But trust me, this is a very easy variety of questions. You just have to know some basic logic behind it and then a very simple trick that can help you solve the questions just in a jiffy. Okay, let us try to understand the logic behind this first. Okay, and then I'll teach you the trick also. So you see, in the first variety, x plus 1 upon x is equal to a is given to you and you are expected to find out x square plus 1 upon x square. Now if x plus 1 upon x is equal to a, now if I square this, then what happens? This is what happens, right? Let me try to open this bracket. It becomes x square plus 1 upon x square plus 2 into x into 1 upon x, right? 2ab. This is equal to a square. Now what happens from here? X square plus 1 upon x square is equal to actually a square minus 2, right? So whatever the value of x plus 1 upon x is given to you, you just have to square it and subtract 2 from it. You will be able to find your answer, right? So suppose say x plus 1 upon x is given to you as what? It is given to you as 7. Let us say x plus 1 upon x is given to you as 7. What is the value of x square plus 1 upon x square from here? Nothing but 7 square is 49. 49 minus 2 is what? It is equal to 47. Easy, isn't it? Very, very simple. When we practice more questions, things will become clearer to you and they will settle in your mind. Okay. But for now, just take a look at this slide and try to understand what I'm saying. Okay. There is nothing difficult at all here. It's very easy. Okay. Now, coming to the second variety, where x minus 1 upon x is equal to a is given to you and you are expected to find out again the value of x square plus 1 upon x square. Again, I can take the same approach. X minus 1 upon x. If I square this, then I have to square the other side also. So it becomes is equal to a square, right? Now, can I open the bracket? Yes, of course I can. It becomes x square plus 1 upon x square minus 2ab, right? So minus 2x into 1 upon x is equal to a square is what I get, right? From here, what do I have? I have x square plus 1 upon x square is actually equal to a square plus 2 because this x and this x gets cancelled, right? So this is equal to plus 2. So whatever the value of x minus 1 upon x is given to you, just square it and add 2, right? Let's try to take an example here. Suppose x minus 1 upon x is given to you as 5, right? And you are expected to find out the value of what? X square plus 1 upon x square. So what will I do? I'll just square this. In place of a, I have 5. So I'll square this and I'll get what? I'll get 25 and I'll add a 2 to it. So what do I have? I have 27 as my answer here. Very, very easy. You can easily see the logic here and you can also see that here I have in the first variety, I have to square the value and subtract 2. In the second variety, I have to square a and add 2, right? All that we now need is the practice. But now see, what happens is the examiners are much more smarter than what we think them to be. Okay. And using their smartness, what they do is they ask you the question in the reverse manner and you are expected to solve that question. So what they may do is they may give you the value of x square plus 1 upon x square is equal to a and they would ask you to find out x plus 1 upon x, right? Or they may give you the value of x square plus 1 upon x square is equal to a and they may expect you to find out x minus 1 upon x. Now, how to solve this kind of a question? Pretty easy, pretty simple, nothing difficult at all, right? Let us first learn the logic behind it and then we will learn a very super fast trick to solve this kind of a question, okay? So, let me start with what is asked to me. X plus 1 upon x. I'm expected to find out the value for this. So let me try to square it. What happens? It becomes x square plus 1 upon x square plus 2, right? So now can I replace this x square plus 1 upon x square with a? Yes, I can because it is given to me in the question and plus 2. Now what is this? This is equal to x plus 1 upon x square. If I take the square root on both the sides, what do I have? I have x plus 1 upon x and I can just take a square root here. Do I have the value that I need? Yes, I already have it. So all that I have to do in such a question is I have to take the value of x square plus 1 upon x square that is equal to a, add a 2 to it and take a square root here. Okay. I wanted to you to see the logic behind it so that you don't have to remember anything. Now you can just apply the trick directly. Okay. So let us take an example. Suppose x square plus 1 upon x square is given to you as 62 and you are expected to find out the value of x plus 1 upon x. What would you do? You would simply take this 62, add a 2 to it and take the square root, right? So what is it? It is equal to square root of 64 which is equal to 8, right? You can check. This is what it will come out to be. Okay. Now let us go to the next variety. How they can change the question. How they can ask the question in the reverse manner. Now in this case, they have again given you the value of x square plus 1 upon x square is equal to a and they have asked you the value of x minus 1 upon x. Again, let us start with what is asked to me. Okay, let me try to square it. What do I have? I have x square plus 1 upon x square, like the previous question. I'm just taking the approach, and this is minus 2, right? So this is equal to x square plus 1 upon x square is what? It is equal to a. It is given to me in the question, right? Minus 2. So what is the value of x minus 1 upon x from here? I can simply take a square root, right? Taking the square root on the both sides, I have got this, right? So what I have to do is I have to take the value of x square plus 1 upon x square, subtract a 2 from it, and just take the square root. Let me try to explain it to you with the help of an example. Okay, so suppose they have given you x square plus 1 upon x square, right? So what is it? It is equal to, let us say they have given it to you as 66. Okay, and you are expected to find out the value of x minus 1 upon x. What do I do from here? I have to simply take that value of a, subtract a 2 from it, and take the square root, right? So what is it? It is equal to 64 square root, which is again equal to 8, right? So pretty simple, pretty easy. We will see how to actually use these, whatever we have learned in the real life, in the practical questions, with the help of some examples that we are going to take ahead. Okay, so now let us solve some questions based on the things that we have just learned. Okay, so the first question based on this concept is find x square plus 1 upon x square if x plus 1 upon x is equal to square root of 47. Since it is the first sum, I'll show you how to do it in the steps. So x plus 1 upon x is equal to square root of 47, right? This is given to me. I square both the sides. What do I get? X square plus 1 upon x square plus 2 is equal to 47, right? From here, what do I have? X square plus 1 upon x square is equal to 45, right? Now, since I was explaining you, I did all these steps. Otherwise, what would I do? I would simply square the right hand side, that is, I'll make it 47 minus 2, that is equal to 45. And how long would this take me to do? This would not take me more than 10 seconds, right? Because I'll read the question, I'll understand the question, and maximum I'll take 10 seconds to solve this kind of a question, right? Now coming to the second part of this question, what do we have to do here? Find x to the power 8 plus 1 upon x to the power 8 if x plus 1 upon x is equal to square root of 6. Now you must be wondering how to do this question. We learned x square plus 1 upon x square. Now let us see. There are some more steps involved here. Okay, so what is given to me? X plus 1 upon x is equal to what? It is equal to square root of 6. Squaring both the sides, what do I get? I get x square plus 1 upon x square is equal to 6 minus 2, right? This is equal to 4. So I have reached x square plus 1 upon x square. What would happen if I square it again, right? If I make a square of x square plus 1 upon x square, right? And this would become 4 square. So this is 16, right? And what would this give me? It would give me x to the power 4 plus 1 upon x to the power 4 is equal to 16 minus 2, that is equal to 14, right? But I have to reach where? I have to reach x to the power 8. So what would I do? I would square it once more, right? Let me square it. Okay, so what happens here? This gives me 14 square is 196, and what does the answer come out to be? X to the power 8 plus 1 upon x to the power 8 is equal to 196 minus 2, that is equal to 194, which is the answer to my question. If you are confused, if you find it difficult anywhere, if you need to relook at it, just pause the video here and take a good look again. Okay, nothing difficult here. It's pretty simple. You'll understand it very easily. Coming to the next question. X plus 1 upon x is equal to 7. Find the value of square root over x plus 1 upon square root over x. Now, for those of you who think this is a difficult question, let me try to reframe it for you and bring it to a form that is familiar to you. Okay, so for the purpose of convenience, what I'm doing is I'm assuming square root of x is equal to a. From here what happens? X becomes equal to a square. Let me place this value in the question now. Okay. So what do I have? A square plus 1 upon a square is equal to 7. And what do I have to find? I have to find a plus 1 upon a. I have to find this value. Now, does this look familiar? Yes, very, very familiar. Now you can solve it very, very easily. A plus 1 upon a whole square is equal to what? It is equal to a square plus 1 upon a square, right? Plus 2. So I know the value of a square plus 1 upon a square, 7 plus 2. And a plus 1 upon a from here, I take the square root from both the sides, it becomes square root of 9, that is equal to 3. And a plus 1 upon a is what? It is nothing but square root of x plus 1 upon square root of x is equal to 3. See how easy and simple it is. There is nothing difficult. The examiner tries to play with your mind. They reframe the questions. So all that you have to do is you have to be able to identify that this question is known to me. It is just that they have put it in a different form. Okay. Otherwise, these questions are not at all difficult. You can directly start from this step otherwise. Okay. And you can solve this kind of a question not in more than 10 to 15 seconds. 10 to 15 seconds is also quite a lot. You can solve these questions very, very easily. See, let's see the next one. In the next question, what do I have? I have x square plus 1 upon x square is equal to 23. Find the value of square root over x plus 1 upon square root over x. Once again, I'll assume square root over x is equal to what? Is equal to a. So in that case, x square becomes what? X square becomes a to the power 4, right? So actually my question in this case becomes a to the power 4 plus 1 upon a to the power 4 is equal to 23. Find the value of a plus 1 upon a. This is actually the question. Now if you remember the previous slide, we saw x to the power 8 plus 1 upon x to the power 8 when we were trying to find out. We went step by step. We escalated step by step, right? So now since we escalated step by step, we have to descend also step by step. Okay. So from here, a to the power 4 plus 1 upon a to the power 4 is equal to 23. Now let me try to first bring it to a square plus 1 upon a square. The whole square is equal to a to the power 4 plus 1 upon a to the power 4 plus 2, right? So this is equal to what? 23 plus 2, 25. So from here, what is the value of a square plus 1 upon a square? I can take the square root on both the sides, right? So this is equal to 5. I have taken the square root on both the sides. Square root of 25 is 5, right? So this is my first step. And what am I trying to find? I'm trying to find a plus 1 upon a. So again, let me take one more step. A plus 1 upon a. The whole square is equal to what? 5 plus 2 in this case, right? So 5 plus 2 is what? It is equal to 7. So a plus 1 upon a, what does it become? It becomes square root of 7. And what is a? A is equal to nothing but square root of x plus 1 upon square root of x is equal to square root of 7. So see, this type of a question is so easy to solve. I have in the second step, in the second descent, I have just placed the values directly to show you how conveniently you can do these type of questions. If you find it difficult, if you are confused anywhere, I would request you to pause the video here itself and take a good look at this question first. You should also try to solve it in your own notebook and see that you are able to do it. Okay, now let us see some sums where the value of x minus 1 upon x is given to you. Okay, so in this question, if x minus 1 upon x is equal to 5, find the value of x square plus 1 upon x square. So it is given to me that x minus 1 upon x is given to me as 5. I square both the sides, so it becomes this. This is equal to what? This is equal to x square plus 1 upon x square plus 2, right? So x square plus 1 upon x square is equal to nothing but 25 minus 2, that is equal to 23, and that is my answer to this question. All that I have done is I have squared x minus 1 upon x and subtracted 2 from it. This is basically the thing that we have done, and this is what the only thing that you have to do in the exam. Okay, this will make your questions quick. Now let us see the next one. x minus 1 upon x is equal to 3. Find the value of x to the power 4 plus 1 upon x to the power 4. This question is a little tricky. Pay attention. X minus 1 upon x is equal to 3. I square both the sides. What happens? I get x square plus 1 upon x square is equal to 9, and this becomes plus 2. This is equal to 11, right? From here, what did I do? I just squared and added 2, right? But in the next step, what do I have to find out? I have to square actually x square plus 1 upon x square, right? So this is going to give me x to the power 4 plus 1 upon x to the power 4, and this is plus 2. So basically what I'll do is I'll square x plus 1 upon square is equal to, the square of this is 121, because 11 square is 121. 121 minus 2 is equal to x to the power 4 plus 1 upon x to the power 4. Students usually commit a mistake here. Rather than subtracting 121 minus 2, they add 2 to it. Okay. So the answer in this case should come out to be 119 for you. Okay. Pay attention. If you need, you can pause the video here and take a very good look at the B part especially of this question. Okay. That we just solved. Okay. Now let us deal with some questions where you have to deal with cubes. Okay. So in this type of questions, what can happen is they will give you the value of say x plus 1 upon x, and they will expect you to find out the value of x cube plus 1 upon x cube, and it might happen vice versa also, or they might give you the value of x minus 1 upon x, and you would be expected to find the value of what? X cube minus 1 upon x cube, or vice versa also might happen, as we have seen in previous questions. So how do you deal with these questions and how do you solve these questions quickly? So first of all, let us try to learn the logic behind these questions, okay? And so that you can apply the short trick quickly. Otherwise, you will have to remember it, okay? Now, x plus 1 upon x. Suppose a value is given to me equal to a, okay? And I have to find the value of x cube plus 1 upon x cube, right? Now, if you look at the formula, the first formula given on the left hand side, it is a plus b whole cube, right? I will make use of this formula. We have got a complete list that I shared with you some time back. You can refer to that also for other formulas. Okay. So in this case, what is going to happen is x plus 1 upon x, the whole cube. This is equal to a cube. This is equal to, I'll expand it. It will become x cube upon 1 upon x plus 1 upon x cube plus 3 into x into 1 upon x. This is what is happening actually, right? Into a plus b, that is x into 1 upon plus 1 upon x, right? So this gets cancelled. It gives me a 1, and it becomes x cube plus 1 upon x cube plus 3 into x plus 1 upon x. From here, can you see one thing? From here, x cube plus 1 upon x cube actually becomes x plus 1 upon x cube minus 3 into x plus 1 upon x, right? So if x plus 1 upon x is given to you and you are asked the value of x cube plus 1 upon x cube, all that you have to do is you have to cube it first, right? X plus 1 upon x, the whole cube. You have to cube it first, and then you have to subtract 3 into the value given to you, right? And in my case, since I have taken x plus 1 upon x is equal to a, so it becomes a cube minus 3a, right? So this is what you have to pay attention to. But it is very important that you understand this logic so that you do not have to remember the things. You can directly just, your mind will be more accepting to them, right? Now let us go to the question given to us and let us see how to solve it. So what is given to us? X plus 1 upon x is given to us. It is equal to 3 root 2 it is given. And I have to find out the value of x cube plus 1 upon x cube. So what am I going to do? I'm going to cube it first, right? So 3 root 2. I'll cube it first, 3 root 2. I'll cube this and I'll subtract minus 3 into x plus 1 upon x is 3 root 2. Right? This is equal to what? 3 is a 9, 3 is a 27, 27 to 54, 54 root 2 minus 9 root 2. This is nothing but equal to 45 root 2. See how easy and simple it is. There is nothing difficult at all. And in exams, once you are quite familiar with this trick, you can directly start from this step, right? You'll start directly from this step rather than writing everything else. And you will be able to solve these type of questions in maximum 15 to 20 seconds, even if your calculation is a little slower in comparison to others. Okay, but these questions are very easy, nothing difficult with them, so never skip them out. Okay, now let us come to a question that is again very popular with the examiners. This variety is also very popular with the examiners. Okay, and the variety is they give you x is equal to some value and they ask you to find the reciprocal of it. Okay, so here they have given you x is equal to 5 plus 2 root 6 and they've asked you to find out the reciprocal, that is 1 upon x. So it is pretty simple for you to do. You will just put 1 upon 5 plus 2 root 6. But the catch here is you are never going to find this option as the answer in the answers. Okay, this answer will never be there in the options. So what are they actually expecting from you? What they are expecting is that you will rationalize it. Okay, so how do you rationalize it? 1 upon 5 plus 2 root 6. Can I multiply the top and the bottom, that is the numerator and the denominator, by 5 minus 2 root 6? A plus B is what I have in the denominator. I'm trying to multiply by A minus B to rationalize it, right? So my numerator becomes 5 minus 2 root 6 and my denominator becomes 5 5s are 25 minus 2 root 6, the square of 2 root 6, that is equal to 4 into 6, that is 24. A square minus B square, this is nothing else. This is what? This is equal, this is same as A square minus B square. Don't get confused, okay? And the value of in the denominator is just 1. So my answer comes out to be 5 minus 2 root 6. So basically for this type of questions, whenever you are trying to find the value of 1 upon x, just change the sign in between the two terms. X is equal to 5 plus 2 root 6. 1 upon x would become 5 minus 2 root 6. But there is a condition here. Okay, conditions apply, right? Conditions apply. And what are those conditions? The condition is that you do not want anything in the denominator. You saw, come back to here, come back to this step. We saw that a square minus b square gave us the value 1. 25 minus 24 was 1. That is why we never had anything in the denominator. When would that happen? When the difference between the two terms, right? 5 plus 2 root 6. The difference between the squares of two terms is equal to 1. 5 square minus 2 root 6 square is equal to actually 1, right? So if the difference between the two terms is, the squares of the two terms is 1, then you can simply put 1 upon x to be equal to 5 minus 2 root 6, right? You just have to replace the plus sign by a minus sign. If you have not understood anything or if anything is difficult for you, I would highly recommend that you replay this much part of the video, right? Because these things should be very clear in your mind before you actually apply them. Okay, otherwise there is nothing difficult at all. This question is very easy. Okay, now let us see how they may twist the questions using this concept. Okay, the question might be given to you. For example, if x to the power 133 is equal to 4 plus square root of 15, find the value of 1 upon x to the power 133. Now see, if you do not know this concept and you directly see this type of a question in the examination, you'll definitely get panicked. Okay, but with this knowledge that you have, this question becomes super simple for you. Okay, so x to the power 133, can I assume it to be y, right? So 1 upon x to the power 133, what does it become? It just becomes 1 upon y. So this is actually a practical implementation of what we just learned. So y for me is given to be 4 plus square root of 15 and I am asked the value of 1 upon y. This is basically what is happening here. Okay. Now, see, first of all, let us check the difference between the squares of the two terms given here. The first term is 4. So 4 square minus square root of 15, the whole square. Okay. So this is equal to 16 minus 15. This is equal to 1, which means my condition is getting satisfied. So for me, the value of 1 upon y is nothing but 4 minus square root of 15. See how simple these questions can be, and you can solve this type of questions in not more than 15 to 20 seconds if you know how to solve these questions, and that is basically what is required. Okay, let us move on to the next question. Question number 18. If x is equal to 5 plus 2 root 6, find the value of x plus 1 upon x. Okay. Now, this is again the similar type of a question. I want to find the value of 1 upon x. So, I have to first of all check my condition. Okay. The condition is 5 square minus 2 root 6 square. I am trying to find out if it is equal to 1 or not. Okay. So, this is equal to 25 minus 2 to 4, 6 at 24. Okay. This is equal to 1. In that case, my 1 upon x becomes what? It becomes 5 minus 2 root 6, right? We have just learned this in the previous question. So from here, what is the value of x plus 1 upon x? It is equal to 5 plus 2 root 6 plus 5 minus 2 root 6. These two terms get cancelled, right? And my answer becomes 10. The answer is 10, but do you notice something interesting here? The interesting thing here is the answer is equal to twice of the value of bigger term, right? So you can directly solve this question actually. If you see that the question given to you is such where the value of the difference of squares is equal to 1 and you are able to find your 1 upon x in this manner and you have to find out x plus 1 upon x, then simply double the value of the bigger term, right? And with this way, you will be able to solve this question very, very quickly. Okay. Now let us see what happens in the other variety of question here. Okay. So this is B actually. Okay. So if x is equal to 5 plus 2 root 6, find the value of x minus 1 upon x. Okay. So we have seen that the value of 1 upon x is equal to 5 minus 2 root 6 here. So x minus 1 upon x, what does the value become? It becomes 5 plus 2 root 6 minus 5 plus 2 root 6, right? This time the 5's get cancelled and the value becomes what? It becomes 4 root 6, right? So whenever you are able to find out the value of 1 upon x like this, your x minus 1 upon x will be, the value will be double of the value of smaller term, right? Directly you can mark the answer. Very interesting, and it a very time saving trick which can earn you a lot of marks also and which can get you the right answers also. Okay, so very, very easy. Let's see what the next question is. Okay, so now you see, you must be wondering what would happen if the difference between the squares of these two values is not equal to 1. What am I going to do to find the value of 1 upon x in that case? Here's an easy way out. Okay, if x is equal to 13 plus 3 root 2, find the value of 1 upon x. So what I would do is, my 1 upon x is equal to 1 upon 13 plus 3 root 2 actually. But the catch here is you are never going to find this in the options, okay? Because they are expecting you to rationalize it, okay? So how would you do that? I would multiply the numerator and denominator by 13 minus 3 root 2, right? 13 minus 3 root 2 because I'm trying to get a square minus b square form, okay? So what happens here is my numerator is 13 minus 3 root 2 now. And my denominator is what? it is equal to a plus b into a minus b, right? So 13 square minus 3 root 2 square. Am I right? So this is equal to nothing but 13 minus 3 root 2 upon 169 minus 3 3 is a 9, 2 is a 18, right? This is equal to 13 minus 3 root 2 upon 151. So what is the trick here to solve this question quickly? The trick here to solve this question quickly is you want to find the value of 1 upon x. You take 13 minus 3 root 2. You change the sign here. Okay. You change the sign here. But in denominator, there is something going to come because now it is not 1. And it is the difference between the squares of the two terms. So that is 13 square minus 3 root 2 square. Okay. So this is quite an important concept which you have to know. Nothing difficult as such here. But if you are aware of this, you can find your value of 1 upon x pretty directly. Okay. Now let us see how this concept translates into actual questions in the exam. You may find directly this type of a question also, that is 19A. But there is a high possibility that the examiner might try to play around with you. Okay. So if x is to the power 45 is equal to 12 plus 3 root 7, find the value of 1 upon x to the power 45. So as I did in the previous sum, one of the previous sums, x to the power 45. Can I take it as y? 1 upon x to the power 45 becomes what? It becomes 1 upon y. Okay. Let me first of all try to see what is the difference between the squares of the two terms of this. Okay. So it is 12 square, that is 144 minus 9 sevens are 63. It is not equal to 1. Okay. It means I'm going to get something in the denominator. So 1 upon y in this case becomes what? 12 minus 3 root 7, right? Divided by 144 minus 63, right? So this is equal to nothing but 12 minus 3 root 7. 4 minus 3 is 1. This is equal to 8. Okay. So see, there is nothing difficult in these type of sums. All that you have to know is what is happening and why is it happening. Okay. And if you know those things, you can apply your tricks directly. Otherwise, it is very, very difficult to memorize everything, memorize all the tricks. Because you see, in every chapter, you will find maybe say 5, 6 tricks or maybe even more in lengthy chapters. How many of them are you going to remember? So the basic thing is the power of concept. If your concept is clear, it is easier to apply the trick also. Okay. So guys, with this we come to the end of this video on algebra. And I sincerely hope that whatever we have learned today in this video is going to be useful to you in solving the questions from this chapter in your placement tests and entrance exams also. If you have found today's video useful, do give it a thumbs up and share it with your friends also. And if you want to stay updated with more videos on quantitative aptitude, the new topics, make sure that you subscribe to the channel because we are going to release a lot of new videos that are going to cover the other topics of quantitative aptitude also. I'll see you very soon with a new video then. Till then, bye-bye. Take care.